time value of money is a very important concept when making financial decisions. I mean, very simply put, the value of $1 today is not the same as the value of $1 in the future. I mean, think about it. If you put money into just a savings account that earns 0.5% or % interest, that money will grow to a larger amount in the future. That's one element of the time value of money. Also, there's this whole thing called inflation. Now, we haven't had huge inflation in this country, at least when I'm recording this video right now, but there's always some element of inflation. Prices go up over time. Just ask your grandparents, okay? My grandparents talk about how gas used to cost $0.05 a gallon, and my grandfather obtained his driver's license from the gas station and paid $0.25. I guess I have to believe those stories are true. I at least know that gas was a lot less expensive back then than it is now. Prices go up over time, generally speaking. So this time value of money is important. Now, in the textbook world, the textbooks like to use time value of money tables. For probably the primary reason is a lot of students may not have a financial calculator available when they're going into a testing environment, for example. And it's just, it's kind of like learning long division by hand when you're young, and then you use a calculator later on to do those kinds of calculations. So what I'm basically saying is, the rest of this video, what I'm going to show you with these time value of money tables, these are not things that working professionals necessarily use in their day-to-day calculations, but they are used in the academic environment to illustrate some of these principles. So let's just take a look at this right here. Now, this is the present value of $1. That means the present value of a single cash flow, a single amount. And this particular table is echoed if you happen to be taking MBA 611, and right now as I'm recording this video, in the Edmonds text, you can find this on page 590. And if you're looking at this video and we're not using the Edmonds text, or if you're not in my MBA course, that's okay. Just look at the index of your book and you will find that almost every accounting book has some version of the time value of money tables. And if that fails, just go to your internet search engine and I guarantee you'll find it. If you really want to get creative, you can take an Excel spreadsheet, and I'm not ashamed to admit I've done this. You can use these formulas to replicate the tables as well. Anyway, let's use these tables here. So Aslam wants to accumulate $200,000 a year from today. Good for him. He assumes a 12% annual rate of return. So we're going to take a look at this column of the table. And because we're only going out 1 year in the future, which is, maybe it's unrealistic, but anyway, here's our multiplier. So basically just grabbing the interest rate per year, okay, and 1 year. Now, keep in mind, this is interest rate per period. If your compounding periods are not annual, if they're quarterly, monthly, whatever, then you have to increase the number of periods and you have to decrease the rate accordingly. But for this purpose, we're just going to assume annual compounding. 12% interest rate, 1 year in the future. The present value factor, 0.89 and some change right there. We can use this to figure out that $200,000 1 year from now is the equivalent of, and let me just write this down here, is the equivalent, and I'm going to round this number to the nearest whole dollar because that's really close enough for what we're doing. It's the equivalent of $178,000 and some change, almost $179,000 today. So what that's basically telling you, there's two ways to look at this. You could say $200,000 in the future is the same, assuming or looking at the time value of money, as $178,752 today. You can also flip it around and you could say, if I had $178,752 today and it grew at 12% interest for 1 year, it would grow to become $200,000. Where we're going to use this information is a lot of times comparing apples to apples. We might be looking at the decision to replace a piece of equipment or make some investment in the future. And we have cash flows happening at different periods of time. Sometimes cash flow year 1, year 2, year 5, year 20, whatever. And we need to have a way of comparing those apples with apples. So one of the techniques we use is to discount all of the cash flows to a present day amount, present value. And that's going to allow us to do something called a net present value analysis. It lets us put everything in the same time period. So maybe you didn't believe me when I said that if you had $178,000 and change and you invest it for 1 year at an interest rate of 12%, that it would grow to $200,000. Well, let me just prove it to you, okay? 12% rate, 1 year, but now we have a different table. Take a look. This is the future value of $1. I'm going to go back one slide here. The table we were looking at a minute ago was the present value of $1. And the multiplier is less than 1 because present value is always going to be a smaller number. And we used that multiplier times 200,000 to come up with the present value, which is $178,572. Now we're using a future value table. So what we're trying to do is we're taking the present value, which we have right here, multiplying times the factor that you find in the table. Notice that it's not less than 1, it's more than 1 at this point. And if you do that math, yes, there's a little bit of rounding involved, but you will see that the future value of this present amount is $200,000. Now you can believe me when I said that those are equivalent numbers. Those first two tables we looked at were present and future values of a single cash flow. So what we're basically talking about with those tables, one amount at one period in time. There are also present and future values for what's called annuities. Now, I'm not going to take a look at the future value of an annuity table with you. Even though that might disappoint you, we're just not going to go there today. I would like, however, to focus on the present value of an annuity. Now, don't get too worried about it says ordinary annuity. All that means is that we are assuming the payments happen at the end of the month, okay? Because the timing does make a difference here. So payments are happening at the end of the month, and an annuity is simply a stream of equal cash flows. Think about the kind of the root of this word here. Annual. You can see it in there. Something happening annually would be an annuity. Now, the cash flows don't have to happen on an annual basis. It could be daily, monthly, quarterly, whatever. But the takeaway is this. They're going to be equal cash flows at equal intervals of time. So we can think about it as years. Now, in this case, we've got Sophia. Congratulations to her. She won $800,000 in the lottery. Now, I've never won the lottery. You have to play it to win it, and I honestly don't play the lottery. But I do understand that there's often this option. Yeah, you won $800,000, and if you want the full $800,000, you can get it. Okay, but you're going to have to take the annuity option. $200,000 a year times 4 equal payments, and that will add up to $800,000. Guaranteed. But the Lottery Commission gives you an option like this. They say, hey, you know what? If you want a full payment, one payment, we'll do that, but we're going to pay you $700,000 right now. So the question is, what's the better option? And the only way to come up with this answer is to compare apples to apples. The $700,000, that's already converted to present day dollars. It is present day dollars. That's money right now. What we need to do is take this annuity and we need to convert it to present day dollars. We need to take those 4 future cash flows. Now you could do it by using the present value of a single dollar amount, that table, 4 times, 1 for each year, or you can more efficiently get to the solution just like this. Take your 12% rate, go over here, it's 4 annual periods in this case, and then back over here for our multiplier. And then all you basically do is take the periodic payment, which in this case is $200,000 per year, multiply that times the multiplier, the factor in the table, and we can see that the present value of this stream of cash flows is somewhere a little north of $607,000. So how can Sophia use this information to make the decision? Look at it this way. If she had this money right now, presumably, if there's a 12% annual rate of return, she could deploy those funds into an investment that would earn 12%. Okay? That's why, as we take a look at this option, the present value of this annuity isn't very attractive compared to the lump sum. So in this case, we would encourage her, at least based upon the quantitative factors. There will always be qualitative factors. Maybe she really needs the money and she's willing to take a little bit of a haircut because she needs cash flow now. That's possible. But if you just look at the numbers, and if this 12% rate of return is a realistic expectation, then she's better off taking the lump sum money right now, because she could deploy that to earn 12% or pay down some debt that might be, might have a 12% interest rate. There are things she can do to benefit her financially. Whereas this money, $200,000 of it comes today, but $200,000 of it comes a year from today, 2 years from today, 3 years from today. It's going to be down the road, and those future payments will not have nearly the present value that the current amount would have. We're still working with Sophia. She still won the $800,000 lottery jackpot, and she still has these two options. She can take the lump sum payment of $700,000, or she can spread it out over 4 years and she'll get the full total of $800,000. But notice a little change. A couple minutes ago we were looking at a 12% rate of return. Now she can only expect a 4% rate of return. Maybe that's what she would expect in her investment portfolio, or maybe her home mortgage and other debt she pays an average rate of 4% on those loans. So maybe she could save 4% of interest expense by deploying these funds to something. So let's see how that changes the answer, because you remember with the 12% rate, and I purposely kept these calculations on the board, with the 12% rate we said, I think she should take the lump sum, because that 12% rate's pretty big and she could do some things with that money. We don't want to wait to receive it. But if we're going to deal with a 4% rate, now we're over here. And we're still 4 years out, and the multiplier starts to look a little bit different. Okay? And let's just cross things out. Still have the cash flow of $200,000, but now the multiplier is, the factor that we figured out right there. And the present value of those cash flows increases. So one of the takeaways is that when your discount rate gets smaller, the present value of cash flows gets bigger. Okay? And a way that you can kind of wrap your head around that is, now it's not such a big deal that she's waiting some time to receive $200,000, $200,000, $200,000, because the opportunity cost is not as great. We're only giving up the chance to earn 4% interest. So now, all other things being equal, quantitatively, we would look at this and we would say, you know what? I'll take the annuity option, because right now, if I take the lump sum, the present value of that cash flow is $700,000. If I take the annuity, the present value of that is a little over, almost $726,000. And I don't know about you, but $26,000 of difference, that's enough to buy a pretty decent automobile or something like that. So I would probably take that option. So a few minutes ago, I told you guys a lie. And believe me when I say it was unintentional. I told you we were not going to go and look at the future value tables for the annuities. And quite honestly, I forgot that I had this example in here. And I don't want to deny you this wonderful opportunity. So let's just take a look at the future value tables. Now, I will explain the reason that I focus on the present value tables is for a lot of managerial accounting decisions, we tend to use the two present value tables. present value of a single dollar, present value of an annuity, because we're trying to take future cash flows and present them in terms of today's dollars. That doesn't mean that the future value tables are useless. Here's a prime example. Let's say that this couple would like to invest $5,000 a year at the end of each year for the next 15 years. They're trying to save for their kids' college education. And a very natural question is, all right, so if we do this, how much money will we accumulate? Now, of course, you could take $5,000 times 15 years, and we can come up with just the gross dollar amount, but you have to consider that magic of compound interest, the time value of money. So they assume 4% interest rate, and what did we say, 15 years? Okay, oh, magically that's, by the way, these tables, they are much bigger than what I've given you here. These are just excerpts, okay? And there's our multiplier. So what you're basically going to do is you're going to take your periodic payment, in this case, $5,000 per year, multiply it times the factor from the table, and that gives you a future value of just over $100,000. So what we're basically saying here is $5,000 a year invested each year for 15 years with interest can be expected to grow to roughly $100,000 if the interest rate is 4%, or if the investment return of those investments is 4%. As we kind of close things up here, I'd just like to reiterate that in practice, professionals are not using tables like this. They are used to illustrate time value of money concepts in the classroom. Realistically, if you're going to be performing present value functions and future value functions, you're probably going to be using Microsoft Excel, some other PC or Mac software, an app on your phone, or maybe a financial calculator. And there is a separate video you can watch that I've put together on how to do some of these calculations using Microsoft Excel as one of those tools. So make sure you take a look at that for some practical applications of the time value of money concept.